Hello everyone, welcome to today's webinar. My name is Paul Fariga. I will be your moderator for today's call. Our speaker today is Jimmy Peck, General Manager at MPW Industrial Services. During today's event, Jimmy will review the current automated technology solutions available for safe and efficient elimination of fouling associated with recovery boilers. I'll now hand over the presentation to Jimmy. Jimmy, begin when ready.
Okay, good morning everybody. I appreciate you logging in and being a part of the webinar today. Very excited to review some of the latest technology and tooling that's out there and available to our industry. As Paul said, we're in the industrial cleaning industry here at MPW Industrial Services. That's one of our service lines. So this first slide is really, may even be hard to read on your screens, but this first slide is really just 2014 safety stats for the pulp and paper industry, the paper mill NCAIS code, as well as the industry that we're in. So the blue is for paper mills, red is for the service industry that we're in. So you can see the recordable injury rate there at the first set of rows, 2.3 TRIR for the pulp and paper industry and 3.6 for the service industry. The total number of recordable cases, 1,600 in the pulp and paper industry and 9,000 in the service industry, and then number of fatalities, 3 in paper mills in 2014 and 8 in the service industry. So the reason we kind of put this slide up at the beginning is to say that this is really the reason for the rest of the presentation. There are some other added benefits to automation, but the primary reason that we are driven to find automated hands-free solutions for cleaning applications in paper mills or in any industry is to keep people safe, keep people out of harm's way. So as we go through this, we'll kind of talk a little bit about each tool and how it has made every job a little bit safer and maybe even the way it used to be done. So again, this is just saying that we are working in a hazardous environment and want to find ways to do it safer. Some of the benefits of automation, the tooling can assist with keeping workers out of harm's way and decreasing safety and quality related incidents. Through hands-free operation, you eliminate the need for workers to enter potentially dangerous spaces. On the automation and the tooling that we have that has cameras mounted on it, you're able to pinpoint location of obstructions or any fouling, and you're able to increase efficiency and decrease downtime with tooling. The robots, they don't have to take a break like people did. So when you're able to use robotics and automation and hands-free tooling, you're able to work 24/7 to get the work completed. And then when there's camera or monitoring device on the tools, we're able to get some detailed and consistent monitoring and potentially even video that work that we're doing. As you can tell by the title of the presentation for today, the focus is going to be on recovery boilers. But as we go through these, I will mention that some of these tools have application outside of, actually all these tools have application outside of the pulp and paper industry as well. So in the utility industry, the steel industry, metals, refineries. So these tools are not confined to recovery boilers. They're also useful in other industries as well. And these are just some of the tools, some of the automation that we have here at MPW and available to us in the industry. There are certainly other tools that we have that may not get mentioned today, and there's also customization possible. So there have been a lot of, and we'll go through some of these case studies at the end, but there have been some situations where we have been faced with a challenge to come up with a solution for a customer that maybe the tool didn't exist. And with our engineering department here, out of Columbus, Ohio, we were able to put a tool together and design and build a solution for the customer. So we'll start with the upper furnace. These first couple are kind of split into the areas of the recovery boiler that the tool is most useful for. So we'll start with the upper furnace. This is what we call our cable crawler. This is intended to be used in the upper furnace, the back pass, and potentially under the nose if there are some entry points. This is for the removal of salt cake fouling in the tubes. This can also be a vertical run, just not a horizontal run on the boiler walls for any fouling on the walls themselves. So this particular tool is an indexing 2D, high volume, high pressure rotating head across the boiler via suspended cables. It's hydraulically controlled from a power pack outside the boiler itself. So again, we're keeping people out of confined spaces. It's got a servo motor driven unit. It's able to push and pull the cleaning heads across the cable. It's got 2 cameras mounted on it, so you're able to see exactly where the nozzles are positioned to put them at the right spot to remove any fouling between tubes or some areas that you might not be able to see from a doorway. The next slide is this is the video here. This is a I guess we probably should have played this, but this is a video of some of the specifics of the cable crawler. You can see some of the cameras mounted there. There's the control box, forward, reverse. You can control the speed, the monitor to see where you're positioned. And again, that tool just crawls along the cable. It's got an automatic mode that'll keep the head moving, or you can stop it and work on one particular target area. Next slide is our Smelt Bed tool. There's actually 2 services we provide when it comes to smelt beds. One is smelt pumping services. So that is for boilers that may not have a sloped floor. It might be a flat floor where smelt stays accumulated even after the boiler is brought down, and we're able to pump the smelt out and into a dissolving tank below. Basically what that does is that'll cool down the recovery boiler faster and enable us to get our water blast tools in there. It also cuts down on the amount of water blasting that has to be done. Some recovery boilers that have a sloped floor may not need to have the smelt pumped. So the tool to the right there is our actual Smelt Bed wash tool. So that is a hydraulically indexed 2D rotating head that goes on the end of a rod. That rod is shoved into the boiler all the way to the rear wall, and it's pulled back to pull any of the smelt that is built up on the boiler floor through the dissolving through the smelt spouts and into the dissolving tank. And we can angle those to hit some hard to reach areas in the corners. So these next 2 slides are about this particular tool. This is our automated tube cleaning set of tools that we have. So we have a single lance machine and a multiple lance machine. That's the SAL 1 and the MAL 3 that you see up there. The single lance machine is a handheld device that's able to drive a lance in through tubes and out. The one that you see here on the video now is the multiple lance machine, the MAL 3. So you're able to run up to 3 lances at once through any kind of tube bundles. The thought here and the application in the paper mill is actually on the evaporators. So the benefits here, you can run 10 to 40 psi depending on the degree of fouling that you have. You can do horizontal or vertical tubes for condensers or evaporators. Got the back out preventers. It's hands-free operation, so our people are able to stay away from the blast zone at the end of the lance. and you can speed up or slow down the rate of the lance. Again, depending on the type of fouling that you're dealing with, you may need to slow it down in order to get some of the heavy off the inside of the tube. So one of the applications for a multiple lance machine would be a tubular air heater or gas over tube air heater in a recovery boiler. In this situation, multiple lances can be used to reduce the dangers associated with a limited work area in a confined space. That is used with the MAL-3 is attached to an XY positioner so that you can do horizontal or vertical tube bundles. So you can see in this picture there's an XY positioner that is controlling the location of the multiple lance machine and driving the lances in and out. It's air powered, and you can use it on tubes of varying lengths and sizes. You can also use different attachments and different heads and nozzles, again depending on what kind of fouling you're dealing with. Typically in a tubular air heater in a recovery boiler, you're going to deal with salt cake buildup. A lot of times it's water soluble, so it can be pretty easy to wash through, maybe with even a fire hose. But there are a lot of times that you get some pretty heavy fouling, and if it's been a while since the tubular air heater has been cleaned, you may need to lance that area. Here we have our line cleaning auto box. So this auto box is very similar to a single lance machine. It is not handheld. It is fixed to either a stand or the hitch of a truck, and you're able to feed the hose through this box and clean lines. Typically it's larger lines than what you're able to clean with a single lance machine. So you're going to use the auto box here for applications like green liquor lines in a recovery boiler. A lot of times you get a lot of crystallization and fouling in the green liquor lines. The auto box is air powered. It's got a remote control device so that the person can stand away from the end of the hose. Typically this was done with a guy standing right at the end of the hose, right at the beginning of the line, and if that hose hydraulically pushed itself back out, there was certainly a lot of danger here for a water blast injury. So in this case, it's actually got a back out preventer. You attach that to the end of the pipe that you're cleaning. You insert the lance, and then the lance and the auto box do the job. It'll clean up to 1,000 feet of pipe, push and pull the lance in 1,000 feet, and again you're able to adjust the feed rates in and out. And it can take hose from anywhere from a 1/2 inch to 1 3/4. Okay, this one's one that we're pretty excited about. This is what we call the M1 RV remote vacuuming system. There's two different models here. The one in the top picture is sort of a serrated snout on the end that's able to have water blast and fire hose nozzles connected and attached to the front, so you're able to vacuum and blast. The one pictured on the bottom is an auger attachment, basically on the same base. So you're able to get harder material with the auger attachment, so a lot more solids. The operator is able to clean with the joystick and a video feed from the outside. This is really good in a tank environment. We do have a case study at the end that we'll talk about where we used the auger attachment to clean a white liquor tank that was tied to a recovery boiler. So that was, again, pretty exciting. This was something that you're able to go in and clean at some pretty hot temperatures as well as hot chemicals inside a tank, and and you're able to remove the human element. The next one's the dissolving tank. This is another remote crawler that we have that's basically either a water blast or fire hose attachment on this crawler. So this is not the vacuum crawler. This is a little bit smaller. It's able to get into some smaller environments and smaller tanks where maybe the other crawler doesn't fit. Here's a picture of the uh, the crawler that we have with the serrated snout on the end. Kind of gives you an idea of the environments that it's able to work in. These are all, again, operated via joystick and video feed from a distance or outside a tank, so no one has to enter any confined space. They're able to enter, all these crawlers are able to enter a standard doorway into a tank. Okay, so a couple case studies here to go through. The first one is actually for a power boiler, but this sort of demonstrates the usefulness of the cable crawler. This was at a Florida pulp and paper mill. They had a challenge cleaning some dangerous areas inside their power boiler, and typically this had been done in the past, very time consuming. Scaffolding had to be set up. It was dangerous. We had to use a short barrel water blast gun, issue a variance to use that short barrel gun, and people had to go in and work in a very tight spot to be able to blast the material from between the tubes. We worked with some of the engineers and maintenance folks at the mill, and they actually cut 2 access points, one on each side of the power boiler, and we were able to run a cable across those access points and put the cable crawler on that. And instead of taking 40 hours to set up scaffolding and clean in the past, we were able to get the job done in 16 hours and save about $37,000 for the customer. We were also able to deliver a better clean. With the heads, we were actually able to reach some areas that were not reachable before with the scaffolding and traditional water blast gun use. So eliminated the safety concern, saved a lot of money, and did the job more efficiently. Okay, the second case study, this is kind of the one I was referencing before. This involves a crawler, and this was at a pulp and paper mill in Virginia. Again, this is kind of why I get really excited about the crawlers, the vacuum crawlers that we have. So we were able, this is, I think when you're looking at this video that we're going to see here in a second, you can think dissolving tank on a recovery boiler or any tank. This tank in particular was a white liquor tank. So again, very hot chemically and very hot temperature-wise. So the issue was getting this tank clean in the past always involved high dollars. It involved cutting a manway into the side of the tank, and they used a bobcat to try to get the material out, and then they would repair the tank. So very costly. We were able to, without any cutting being done on the tank, we were able to use the M1 RV with the auger attachment on the front. So here you can see a video of this. This was the actual tank from this case study. You can see the white liquor mud there at the bottom. We spent the first day getting a lot of the really wet material cleaned up, and then we were able to go to work on the solids. And so we went from a job that typically took 2 to 3 weeks in the past to getting it done in a week and saving a minimum of $40,000 for the customer. They were extremely excited about this, and they've already come up with another half a dozen ways that we could use this particular crawler with the auger attachment. So we're actually getting ready to do a green liquor tank for them here next week. So pretty exciting stuff. And actually, while we were doing that tank with the crawler, there was an avalanche of material that fell and knocked the crawler back about 8 feet. And, when that happened, the customer was there. I was actually there on that job. And we had a conversation about, if that would have been people inside that tank. So and that crawler was able to back out and just continue to work on the material. So it was pretty good. This next slide is some locations where we have used some form of this automation in the past. But before I pass things back to Paul here in a second, I want to kind of issue a challenge, a safety-based challenge to anyone on the call that comes from a pulp and paper operations background. So if you're working for a pulp and paper mill, if you're one of the owners or operators there, here's the challenge. We've seen more success using automation when it has been embraced by the owner. When the customer that we're working for embraces it and says, I want to see this, I want to see how we can use this, I want to see people be safer, people out of harm's way, we've seen more success. When we have some customers, believe it or not, that say, this is the way I've always done it for the last 20 years, the last 30 years, I know it works and I don't want to change it, it can be a challenge for us to introduce some new ideas. So I think one takeaway for everybody on the call is to go back and challenge yourself, challenge your teams, and say, how can we incorporate technology, whether it's from MPW or not? How can we get people out of harm's way? Because our goal by the end of this year is to be 100% automated. And we're getting closer and closer to that on a daily basis. We've recently made a larger investment in more of these automated tools and getting them out to all of our locations. So we have definitely accepted the challenge, and I hope you do too.
All right. Thanks, Jimmy. Okay, folks, we'll now open up our presentation for our Q&A session. And our first question, Jimmy, is, can you use these products for corrosives or flammables?
Yes, the white liquor was actually the white liquor tank that we were working in was actually pretty corrosive. We had to clean the crawler up pretty good when it was finished up. So yes, we are able to use it for corrosives. Flammables, it would depend on what tool we're talking about. Because that answer would vary. Not everything that I went through was intrinsically safe. Anything with the servo motors on them would not be intrinsically safe. There were a lot of things up there with air motors and air driven that are non-sparking that would be safe in that environment. It would just depend on the particular tool.
Okay, great. Thanks, Jimmy. Can you talk a little bit about the financial implications on the automated tooling and reducing customer downtime?
Yeah, I think through a couple of the case studies, we talked about the financial impact of a couple jobs, but I do have some other examples that are kind of outside of the recovery boiler or paper mill environment. There was one thickener tank at a utility in central Ohio where we used one of the crawlers without the auger attachment to clean the thickener tank with a water blast nozzle on the front. So basically we were washing the material down through the center well of the thickener. And typically that had been done with people inside the thickener tank and washing material with a fire hose. So in this case we converted one of the crawlers to be able to use a blast head on the front, and instead of taking 6 shifts, which is what it took in the past by hand, we actually got it down to a day and a half or 3 shifts. So we were able to cut that job in half. So almost every job, I mean, I could go through a lot more. I love talking about the ways that we're able to use tooling and the savings that it brings. The bigger the job, the more savings it brings, really. I mean, I haven't seen any job yet. So the thickener tank I was talking about, that was just a 3-day or 6-shift job before, and we were able to take it down to a day and a half or 3 shifts. So, you know, obviously the bigger the job, the more the impact will be.
Oh, that's great, Jimmy. So in that example, essentially a 50% savings in terms of time.
Yes, and also the same with the white liquor tank that I was talking about. The case study there at the end, that was a 50% savings as well.
Great. So you mentioned earlier today that there are other industries where this technology could apply. Could you share a little bit more about that?
Yeah, so the example I just gave was in the utility industry. So we've used the crawler quite a bit in the coal-fired power plant industry. There are a lot of applications, thickener tanks and coal yard applications. We're able to use the crawler. There in refineries. There are a lot of tube bundle work, refineries and chemical plants. There's a lot of tube bundles, so we have a lot of application for the multiple lance machine in those environments. So I mean, it really kind of depends on what industry, but if anyone has a specific question on one industry in particular and would like me to go into depth a little bit more on that industry, I'd be certainly willing to do that.
That's great, Jimmy. Can you talk a little bit about some of the limits and the tolerances of the products? For example, what's the highest temperature that these products can withstand?
Okay, this is one that varies by tool as well. So the crawlers typically will work in an environment up to 250, 275 degrees. That's what the track is able to withstand. So that's kind of the weakest point there. The smelt bed tools, for example, those are able to withstand 600 to 800 degrees. So, typically they're able to go into a recovery boiler pretty quick after it's shut down and kind of the initial wash down from the soot blowers. In fact, we typically will insert our smelt bed tools at the same time that the soot blower wash is going on. So again, that's just another way that we drive efficiency on a job. That was something in the past that you'd have to kind of run the soot blowers and do the wash first to remove any overhead hazards, and then you would be able to go in and clean the smelt bed. But with the tools that we have, we're able to clean the smelt bed simultaneously as the soot blowers and as the cable crawlers work to clean the upper furnace up above.
Okay. Thanks for that explanation. That was great. So our last question, earlier you talked about the couple of examples with the 50% or so savings in terms of time. For our participants, is there a rule of thumb that they should be thinking about when they're looking at these products and this technology in terms of estimating what the savings might be or the gains in time?
I don't know that there's a typical rule of thumb. I wish there was. The few examples that I've kind of shared on the call and been familiar with or involved in have been 50% savings. I've seen anywhere from 25 to 50% savings on a job when using the automation, when we're using the crawlers. I can give you one example where you don't see as much savings. So if you're using a lance on a small tube bundle, let's just say it's 20 tubes in a small tube bundle, and you've been doing that by hand, and that job probably didn't take that long. So by the time you set up a multiple lance machine with an XY positioner and you do that job, it's going to be about the same time and probably about the same price. But when you get to a set of evaporators with thousands of tubes or hundreds of tubes, and you set up that multiple lance machine and you're able to run it, and it doesn't take a break. The only person taking a break is the operator, and he switches out with someone else. So when you look at it in terms of the magnitude of the job, that's when you're able to get the more savings. So the examples I used were kind of larger jobs. There are times where the smaller job, like the small 20 tube bundle that I was talking about, you may not necessarily see savings there, but you will see a job done safer and potentially more efficient. You're certainly going to get a more consistent clean on the tubes.
Excellent. Great explanation. Thanks, Jimmy. And that concludes our program for today.